So I'm Naphan, CTO of Fujitsu Network Communications. I'm going to talk to you very quickly, feed it through a fire hose to keep it within 8 minutes, on how SDN and NFV and Packet-Optical networking platforms can help to continue the profitable evolution of our service provider networks that they've undergone over the last 30 years. First, let's start with a few megatrends. Of course, mobility, cloud, and connectivity are driving an awful lot of demand for network services. That's good. The downside is that there are business model challenges that our network service providers have, and specifically about how costs scale in their investments relative to their ability to generate new revenue with the network that they're investing in. If we examine that problem a little closer, we look at first the very classic familiar chart which shows the single-digit revenue growth for network service providers versus a double-digit bandwidth growth, 30 to 50% depending on who you're talking to. That chart is not new, you've all seen it, and it clearly doesn't look sustainable, but it's only half the problem. The other half of the problem is the competitive business model, and here actually the over-the-top competitors, service providers, versus the network service providers have nearly an inverted business model. The network service providers are investing nearly 3 times the CapEx to revenue ratio to achieve a 1/5 the revenue growth of an over-the-top company. And the triangles in the center are my little cartoon to show the structure of how they spend their capital. And you can see clearly that the big difference is the need to invest in the network versus the applications which are driving more customer relevance and customer interest. And so it's a good news, bad news story from an equipment provider perspective as well as from the network service provider perspective. The good news is that we as an industry for both routing and optical have kept up with the revenue per bit decline, which is that top line, in terms of the cost per bit that the service providers have been spending in their infrastructure to support that bandwidth growth. So this data comes from analyzing financial statements across the industry, and it shows that our cost per bit as an industry has kept up. Optical is the bottom line, router is the second from bottom, red line, those are cost per bit, and the revenue per bit is the top line. And so the net effect is that packet-optical equipment innovation has kept pace with the bandwidth growth. And largely that's been done through increasing capacity. So in the early 80s, a lot of the fiber was laid. Of course, it continues to be laid. And now we've increased the capacity by changing out terminals and regenerators. And we've done this at a rate from hundreds of megabits in the early 80s on a fiber to nearly 10 terabits on a fiber now in actual deployment. And of course, it also has side benefits of power, distribute power consumption, and so on. And while we continue to innovate into 400G and 1 terabit transmission at a wavelength level, we are seeing a challenge to this continued cost per bit reduction through capacity increase. And that Shannon's limit starts to be a burden as we look forward. And so we have to look for ways beyond just the simple cost per bit reduction and really focus then on the OpEx and revenue sides of the problem. And if we look at how to sustain the cost control and help customers generate new revenue, we have to start by addressing the challenges. Of course, time to revenue is a big one. Even if the fiber's in the ground, the time to turn up a new service can be 3 months in many cases. Service evolution is the challenge, and this is the time it takes to create and innovate on a new service. And it's slow because of the tightly coupled service logic with proprietary hardware systems dependent on some specific vendors. And thirdly, and very importantly, is the efficiency with which we connect cloud orchestration from the data center to the network is not completely there yet. We have limited extended cloud or distribution of cloud technologies into networks. And lastly, and very importantly, is the fact that we're dealing with introducing new technologies and new capabilities at the equipment level into an OS environment that's 30 years old or older. And as you know, software doesn't grow very well, it gets pretty long in the tooth, and it makes it difficult to introduce some of the new capabilities both in time and cost. And so we need to address these challenges by leveraging the existing assets, but also avoiding some of the things that got us into this place in the first place, which is a lot of the vendor lock-in, specifically in the software layers. And so the good news is we have a vision for how we can overcome these challenges, and it starts by looking at each of the aspects of our industry, the first being equipment. Through commoditization and disaggregation of the software and the hardware, we can evolve the equipment in the network to be more open and plug and play. The networks themselves will leverage software-defined networks and SON technologies to provide abstraction and virtualization and make the network more dynamic. This is a hardware problem as well as a software problem. The hardware has to become programmable. Thirdly, the services, and this is where the NFV, Network Function Virtualization, and the convergence of IT will drive network services to look more elastic, programmable, and automated, much more cloud-like. And finally, where that leads us is to providers that can move from connectivity to using technologies like network as a service and network data center networks or extending cloud into networks. This is very consistent with the MEF's third network concept. Service providers can then offer their own native services, native applications, as well as provide their network as a service to other over-the-top companies and change the economics of the value that they deliver to over-the-top companies in terms of revenue for the network service provider. And so it's our belief that SDN, Network Function Virtualization, and having a dynamic programmable packet-optical layer are the three key long-term disruptive technologies. If we look at how this might get architected, at the center of it all is the SDN control environment. And here what we need is an intelligent abstraction of network equipment, network logic, and service logic, along with automation through policy control, device controllers that both federate and scale through distribution of control logic, as well as provide mediation to legacy systems and native OpenFlow and NetConf types of new open protocols. That needs to be orchestrated and integrated with an NFV platform to deliver application delivery of new services. And it needs to have open multi-vendor interfaces to the networking infrastructure, which obviously in the digital realm is programmable, but in the optical realm has been fairly static. And so adding dynamic ROADM capabilities through colorless, directionless, potentialist is a key aspect of that. Another very important point is that we need to help customers transition into legacy OSS and orchestration systems. And so system integration and service capabilities is really key to do that. And with that, we can solve real network problems of multi-layer path computation, network defragmentation, policy-based automation, capacity management, abstraction, visualization, and service chaining. These are things we can do today in many cases. And lastly, the big picture here is that what we're seeing is the IT-ification of networks, where network and IT technologies collide and can be converged. And having those services capabilities is really key to help our customers make that transition into the SDN and NFV, supported by a programmable packet optical networking infrastructure.